Good morning, guys. Today we're gonna talk about a problem faced by most systems following the event driven architecture, specifically dealing with messaging systems like Kafka, Azure Service Bus, RabbitMQ, and so forth. So the problem here is that these systems, by design, when they built it from the ground up, it was built to deal with small messages and for high volume of messages. Again, small messages and high volume of messages. So in a traditional event-driven architecture, you have your message broker in the middle between a producing application that sends messages in an asynchronous fashion and keep its processing, its compute power to process additional requests, not blocking the calls for incoming requests. On the other side, consumer services pick up these messages, do the necessary processing, and call probably an external system, commit that message, and pick up the second message. What happens usually is that in normal cases, small messages is well processed, but whenever a large message enters into play, a producing service sends you a message, let's say, with a 2 megabyte size exceeding the 1 megabyte limit imposed by the message broker. That's where the problem starts to cascade. Usually, the first option we revert to is to increase this limit. That's something I learned not to do. I learned to stick with the default configuration settings of any vendor because usually, guys, a data system like a database or a message broker, they do these constraints for a certain reason. So exceeding the limits on the broker itself, to me, is not an option, at least not anymore. Plus, some brokers, some message brokers, will give you this feature for a premium cost. So you are increasing the cost by increasing the default message size, plus when you have a message that exceeds the default size, you will be dealing with performance problem as well, since all consuming services will have to deserialize this specific message. It has to decrypt the message, deal with it, encrypt it, and send it back if the need is there. So performance is going down for that reason. So That is the main problem affecting cost and performance. How do we usually solve that specific problem without increasing the cost and affecting the performance of the consuming applications negatively? Not to mention that when you are on the cloud and your broker is billing you on the egress side, then let's say I have been into a situation recently where, guys, the team was allowing the message size to reach near 1 gigabyte size. Damn, that's absolutely nonsense. Can you imagine dealing with such messages on your message broker? I couldn't imagine that when reviewing that code. Anyhow, let's go to the pattern and the solution we have in hand. It's called claim check pattern. The idea here is simple. Whenever you detect a large message, let's say greater than 1 megabyte default limit imposed on the broker, you don't send it to the message broker, you send it to a file storage service like Amazon S3, Azure Blob, and Google GCS. After making sure the file is uploaded successfully, you go and produce a tiny message under the message size constraint, and this message has a token that points to that specific file in the file storage. And the job of the producer here is release to receive other messages from incoming application or internal or with other vendor or partner organizations. Now, consumer services, on the other hand, will pick up this tiny message and detects that that points to an external file or a large message. Then it attempts to download that payload message from the cloud storage, do the necessary processing, and commit that message. That's the idea, guys. You are released from the performance bottleneck that was there. No more serialization and deserialization, encryption and decryption of messages of 100 megabyte and or alike. From the cost perspective, you are still in a fine situation, still under the limit, committing to default constraints imposed or recommended by the messaging system. You can even go into message brokers that are cost effective, that are affordable for this specific pattern. Now, the other advantage which is a result, Sometimes this kind of messages, they can be XML files that include some payment information or like dealing with systems that pays the salaries of employees for a certain government institutes. This kind of stuff cannot sit in the message broker because usually message brokers have an analytics system listening to it that posts its logs to a certain dashboard, and this dashboard usually has lots of ops teams looking at it. So sometimes you don't want the messaging system to have this kind of sensitive information. You can secure that with an external file storage with a necessary access tokens there that is usually limited by scope and time. Now there are several things you need to consider before implementing this pattern. The first thing that happened with us is after implementing or when we thought about that pattern is that developers they wanted to always go with the file storage and send tiny tokens to the messaging system. That's an extreme opinion. Whenever you go into an extreme decision or an extreme opinion, guys, or in other words, extreme leads to a bad place. Always try to stay in the middle when you take architecture decisions or software design decisions. So the idea here is that you only send this payload to the external file storage if the message exceeds the size limit. So only for large messages. For smaller messages, you keep the normal flow. That's the first thing to consider when implementing this pattern. The second one is you need to think about deleting these claim check tokens from the messaging system here, and then also attempt to delete that file from the file storage, that large file system. You don't need that file to stay there for a long time because already this message was processed. Unless you don't have a way to log this kind of stuff, or you need that for like 1 year, or depending on your logs retention policy. So to contrast this, imagine going into the airport, taking your baggage with you into the plane, each one doing the same thing, then the plane probably won't start even. It won't be able to move probably because you're gonna exceed the allowed size, and it is not realistic as well. So the claim token here is similar to the ticket, to the baggage ticket you get once you log your stuff in the belt there. Your baggage go into the file storage, And once you reach your destination and want to get access to your baggage, you have your ticket that lets you get that baggage back. That's it, guys.